Okay, right. In my last video, we went through how to work out the pH of a weak acid. Now this one, we're going to go through how to work out the concentration of a weak acid. This is Mr. T here, and hopefully by the end of the video, you can do these calculations by yourself. So I'm going to go through generally with the first example here, and then I'm going to work through about 3 or 4 different examples that I've got down. Okay, so here I've put down a well, let me just put up here our general equation for weak acid reacting with water in dynamic equilibrium. Oh, sorry, H2O. So what we end up with is H3O plus, remember, and A minus. Okay, so we can write an expression for this, and remember the expression goes like Ka equals the concentration of H3O plus times the conjugate base concentration over the weak acid concentration. And remember, because we had that the concentration of H3O plus is equal to the concentration of A minus, for every time you make a hydronium ion, you make a conjugate base, that we can say that Ka equals H3O plus squared over HA. Now, when we wanted to work out the pH of a weak acid, we rearranged this equation and made the hydronium ion the subject, and we found the concentration of hydronium ion, and then we converted it to pH. When we want to find the concentration of a weak acid, we actually want to make the weak acid concentration the subject, because that's what we want to find out the concentration of. So to make HA, the weak acid, the subject, all that I need to do is multiply by HA. Okay, so multiply this side by HA. Oh, HA, it's a bit messy there. These cancel out, and then I'm going to divide both sides by Ka. They cancel out, and voila. Okay, we've rearranged. Easier way to think that is if we have something on the top, on one side of the equation, when we move it to the other side, it goes on the bottom. There we go. So this is what our expression should look like when we want to find out the concentration of the weak acid. So someone's told us here we've got a weak acid called hydrogen fluoride. It is measured to, well, hopefully, this what they're talking about here, to have a pH of 5. What is the concentration of HF in the solution? Well, they've told us that the pKa of HF is 3.17. Hey, you know what? We have to change this to Ka before we can put it into here. Now, to change pKa to Ka, we need to do exactly what we need to do to change pH to H3O plus. So we need to the Ka equals 10 to the negative pKa. So we've got to put this into our calculator. So I've got shift. Oh, where is this button here? Shift log and negative 3.17. Okay, so we've got 6.76 times 10 to the negative 4. Our Ka equals 6. What did I say that was? 6.76 times 10 to the negative 4. Times 10 to the negative 4. Now this is doesn't have a unit, a Ka. It's kind of like a Ks. It doesn't have a unit, so we can just leave it like that. But now we're ready to chuck that in here. Well, not quite, because they've told us the pH, and of course, when I want to find the concentration of H3O plus, we do exactly the same type of calculation, and that is H3O plus equals 10 to the negative pH. But since the pH here is 7, this is a rather easy calculation, because this is 10 to the negative 5. Right, so we put these in here to find, let's go through and do this. So we've got, let me just scroll this up a bit here. So if I take HF, here it is, I react it with water. Okay, and we're going to get F minus plus H3O plus. Okay, remember we know here that the concentration of F minus is approximately the concentration of H3O plus. So after we write our Ka expression, which is F minus times H3O plus over HF, we simplify this, and then we rearrange to make the weak acid the subject of the equation. So we get H3O plus squared over HF concentration, and we end up getting that the concentration of HF, or our weak acid, equals the concentration of H3O plus squared over the concentration over the Ka. So we put these values in here that I worked out above. So we have 1 times 10 to the negative 5. Sorry, see up here, I should have put 1 times. And we square that, because that's the concentration of H3O plus. We put it over our Ka, which is 6.76 times 10 to the negative 4. And I'll work out what that answer is. So let's just do this on the calculator. And divide 6.76 exponential negative 4 equals, I don't have this in standard form, 1, 2, 3, 4, 5, 6, 7, 1.50 times 10 to the negative 7. 1.40 times 10 to the negative 7. So where's that? Okay, putting that into a calculator. HF, concentration. Okay, so concentration is in moles per litre. And I have this to 3 significant figures, so that's looking pretty good. What else have I put here? Okay, that's fine. So we've got a couple of examples here to practice and go through. So look, I recommend you stop the video, go through, and I'll just show you some of the answers to these. Okay, so the answers. So the answer to this one here is, first we want to find the Ka here before we can work anything out. So that equals 5.13 times 10 to the negative 10. Okay, and the final answer here gets to the concentration, the hydronium ion concentration once we carry out the calculation, equals 5.1. Sorry, what am I on about? 1.00 times 10 to the negative 6, and that actually equals the pH of 5.74. That's our final answer. So look, just go through, look at the calculations above if you're not sure how I got to those. I'll just write the answers down for these ones. Again, the Ka, we have to work that out first. Okay, in this case it's 6.76 times 10 to the negative 4, and our concentration of H3O plus when we carry out the calculation equals 2.66 times 10 to the negative 2, and that gives us a pH of 1.57. So when we go down to the next one, again we have to change this into a Ka, and we get a Ka of 0.01. Also 112. When we calculate H3O plus, the concentration of that equals 0.0161, leaves our pH to be, here look, because we've got 0.01, that's going to be something round about 2, and look, in this case we get a pH of 1.79. Okay, the last one, when we're working out the pH, look, make sure you do all of these and go through all of these calculations, because they're really good practice. So pKa of this, we turn the Ka into 0.17 times 10 to the negative 10. Okay, so now we work out the concentration of H3O plus. And remember, we're just multiplying these two answers here together and then doing the square root of that to get H3O plus. And in this case, the answer is 1.81 times 10 to the negative 7. Now, I'm pretty comfortable that's the right answer because, look, if I multiplied 5.31 times 10 to the negative 5 times 6 times 10 to the negative 10, I'm going to get an answer about negative 14. And if I do the square root of that, I halve the exponents and I get an answer of about negative 7. So I'm happy that my answer is in the order of magnitude that it's correct. If you didn't understand anything I'm talking about there, then just don't worry about it. Okay, the pH here equals 6.74. Okay, so as well as that, we'll practice. Look, just stop here, go through, practice these calculations. I'll just put the answers up here so you can check them. So in this case here, we had to work out change each of these to H3O plus concentration. Okay, and that equals 1 times 10 to the negative 5 moles per litre. And then we had to work out the Ka, and that equals 5.75 times 10 to the negative 10. Now remember, we do this here by doing the inverse of the log, and we're just putting these numbers here to the negative there, to 10 to the negative or whatever that number is, and it will give us the value we need. Now, when we're working out the concentration of the weak acid, remember, we're just squaring the concentration of hydronium ions and dividing by Ka. And in this case, in the first one, it gives us an answer of 0.174 moles per litre. And that's the concentration of this boric acid. So let's put that down just so that we have this right. Okay. This go to the second one again. We want to find out the H3O plus concentration. So we put that pH into 10 to the negative 3.12. We get an answer of 6.17 times 10 to the negative 4. And then we want to work out the Ka, and we get an answer here of 7.08 times 10 to the negative 4. Hey, look, these exponents are always going to be a number that is 1 bigger than what the number on the left here is. I mean, if the number on the left here is, if it's a 3.0, the number is going to be negative 3. But if it's 3 point something, the number is always going to be negative 4. If it was 9 point something, like 9.23, the number is always going to be negative 9. That's how the exponents work. So this exponents are directly related to this value here. And that's what happens when you do a log of something. So the answer here for this is the concentration of nitrous acid is going to give 5.38 times 10 to the negative 4 moles per litre. Okay, quickly going to go through the next ones. Again, H3O plus concentration, 5.49 times 10 to the negative 5. The Ka is 1.82 times 10 to the negative 4. And then when we work out those answers here, the concentration of our formic acid, this is what we call methanoic acid, gives us 1.63 times 10 to the negative 4 moles per litre. Last one, answer here is 0.0114 moles per litre, and you might wonder why I'm going so quickly at the end here. Well, look, the reason is that I've got to keep this video under 15 minutes, and I'm coming up to the mark now. So this has been the video on how to work out, or how to go through the concentrations and pHs of